welcome back everyone. We're going to do some more calculations. Now we're going to start doing a little bit more the sort of calculations you're going to get in tests and exams, okay? So, a bird flies 100 meters east. Then it flies 60 meters west. So the questions are: represent the movement in a diagram. What distance did the bird fly? And what is the bird's displacement? Now I'm bringing in stuff that we've done before and we're combining it. So here we go. We want it as a diagram. So this is not to scale. This is just a sketch diagram. So the bird flew. I'm going to make that north up. Okay, so I know where north, south, and east is. And they tell me that the bird flies 100 meters east. So there's my 100 meters. Then it flies 60 meters west. So it goes this direction, 60 meters. We've got the diagram. We've represented it in a diagram, okay? So now they say, what distance did the bird fly? I'm just going to put the diagram again to make it easier for us. So there we've got the 100. There we've got the 60. It's not to scale. Distance simply means that I add everything together. So I'm going to go 100 plus 60, 160 meters. Because that's what the bird actually did. It went 100, then it went 60. That's its distance, okay? And it's tired. It went 160 meters. Now they ask us, what is the bird's displacement? If I drew this with a scale diagram, so there's my 100 meters, there's my 60, I know now that her displacement, I'm calling it a her, is from the start of the first one to the end of the last one. And hopefully, you guys can see that that would be 40 meters. Okay, and in which direction? Because we know originally that was east. So her displacement, which we're going to call delta x, because she's changing direction in the x value horizontally, is 40 meters east. But what if I told you that I didn't want a diagram? That I want this done with a calculation? I mentioned earlier that displacement is a vector. Because it's a vector, it can be described as a positive or a negative. So I have to choose a direction to be my positive direction. I'm going to take east as my positive. Why? Simply because it was the first direction given. Sometimes we're going to tell you what direction we want as positive, but most of the time we're not. You must choose one that makes sense to you. What I like to do is always choose my first direction as my positive direction. Because if I do my calculations the same way every single time, I'm not going to get confused. So I'm not going to spend time going, ooh, which direction must I choose? First one mentioned. It doesn't matter if your answer ends up being negative, because you can work out what that means, okay? So that means for me that my first distance, okay, was 100 meters, and that's positive. My second distance was 60 meters west. That makes it minus 60, okay? That minus isn't a negative number like on the number line. That minus tells me I changed direction. So that minus is important. To calculate my change in x, I need to take my first distance and I need to add it to my second one. So I have 100 plus minus 60, Now, if you need to use your calculators, use your calculators. I can do 100 minus 60. So I get 40 meters. I get a positive answer. That means that this is 40 meters east. I wanted displacement. Displacement is the change in position. So I want to know where the bird was relative to where it started. So I could tell someone, go find the bird. The bird is 40 meters east of where I am now. They can find the bird, okay? They don't need to go 100 and then 60. They can just do the 40. So a group of friends go on a hike. They first walk 60 kilometers west. They rest a little bit. Then they go 10 kilometers east. They rest again, and then they go 4 kilometers west. Sure, it's not something I'd want to do. I'm going to be honest. So, first question, calculate the distance covered. Distance, I don't care. So they've gone, west, let's make west that way. So they went 6 kilometers. Then they went 10 kilometers. And then they went 4 kilometers. Okay? And we can hopefully all do this, but they want distance. Distance means I'm going to go 6 plus 10 plus 4. Okay? We like questions like this because this is nice, easy maths for us. Okay? If you need to use your calculator, then let's do that. Okay? So let's put it over here quickly. So we've got 6 plus 10 plus 4, and we get 20 kilometers. Now note, I haven't told you how long it takes them to do this, right? I'm pretty sure if I was doing this, I would have rested way before the first 6 kilometers. But that's distance. Now, okay. Oh, there it is. I lost where that went. So, wrong way. There we go. Now they want the total displacement. Displacement means I need to choose a direction as positive. I said to you just now, we'll take original direction as positive. So my first one is 6 kilometers, and I'm taking west as positive. I like to write down what I'm taking as positive to remind me. My second distance was 10 kilometers east. East now becomes my negative direction. So that's minus 10. We're going to go, third one is 4 kilometers west. All right, so my displacement is my 3 positions added together. So it's going to be 6 minus 10 plus 4. So let's see what happens now, okay? So let's put this over here, and we've got 6 minus 10 plus 4. Oh, look there. Gives me 0. What does that mean? Now, first of all, we get 0 kilometers. This means they ended where they started, okay? I can't give a direction to this because they've gone nowhere, all right? So they really walked 20 kilometers for nothing. I would have just stayed there and waited for everyone to come back, okay? So their displacement, their change in position is 0. This is going to become important when we get to velocity and speed, okay? So calculate their position at the second stop. So they would have gone 6 kilometers west, first stop. Then they went 10 kilometers east. You can't change which direction you want as positive. Okay, so in the last part of this, we went west is positive. I have to stick to that. You can't change your mind along the way. So we've still got west as positive, okay? So x1 is 6 kilometers, x2 is minus 10. So changing x1, x2, 6 minus 10. Let's just make sure, 6 minus 10. Ooh, look here. I get minus 4. The minus means that it was going east. We can't leave it as minus. So x is 4 kilometers east. Doesn't matter, the negative just tells me direction, okay? One last question. Aeroplane flies 100 kilometers east, 200 kilometers south, and finally 100 kilometers west. We want to know how far it flew and what its final position is. So if we go to the first one, how far did it fly? Far means, oh really? Far means distance. So distance, it went 100, then it went 200, then it went 100 again, so that's 400 kilometers, okay? We don't care about displacement. Then they say, what is the final position of the aeroplane with respect to the starting point? And it sounds more difficult than it is, because the plane went 100 kilometers east, then it went 200 kilometers south, and then it went 100 kilometers west. And hopefully, you guys can see that what we've done is we've created a triangle, a rectangle. There's its displacement. It would be 200 kilometers south. I can't calculate this with positives and negatives because we went at right angles to each other. But I can still get the displacement because it's a nice diagram, okay? It's something that we can look at. It's geometry. It's things you've done before. They're not trying to trick you with something like this. I just need you to see that sometimes we can't just add them. We have to actually draw a diagram for them, okay? So, lots was done today, okay? Lots for you to think about, but we are done for this lesson. So, I will see you next time.